Okay, good morning my dear students. Today I'm recording without my microphone. Actually before this video I happened to record one video. The length of the video is 20 minutes, okay, and I just tried to upload it but without any audio. Very angry today right now. I'm not angry with you, okay? This camera especially is so bad, this one actually. Anyway, today I promise you that I'll be solving those two questions. If I'm not mistaken, the first question is asking you to, to make the statement of Newton's laws of gravitation, and after that you need to define universal gravitational constant Z. That is why you have to do that, right? So okay, before I solve the question here, I just want to tell you here, I'm very happy to say that most of you, almost, not all of you, but around some 60% of you have responded well, and you have submitted your assignments in time. But next time, please try to submit within 1 day, okay? If you submit very late, I may not be able to check your assignments properly. So I'm very happy and happy for those who are able to send the assignment in time. And some of you have not submitted the assignment, and I feel so sad for you. And I don't think that is too difficult question. At the same time, making the answer, taking the picture, and sending is not that difficult job. You can do that. And another thing, what I want to tell you is that whether your answer may be right or it may be wrong, it doesn't matter, okay? So you just try to send the answer, and making the judgment should be done by me, okay? Whether it's right or wrong, it doesn't matter. But you try to have the confidence to send your answers to me, okay? Okay, so if you look at the first part of the question, I tell you one more time. The question was asking you to define to define the laws of gravitation. I introduced in the last time also. Let's just I'll move the camera down and you can see it better. So so sad today. I recorded whole session and no audio. Still it's playing in the YouTube right now without any audio. You totally useless. I'm wasting my time also. Anyway, this is the second recording video. Same thing I'm recording again. In the statement, you need to consider two masses. So this is M1, this is M2, and they should be separated by a distance of r here. Then Newton's laws of gravitation says that it states that the force of attraction, okay, between two masses or two bodies, you can say two masses, is number one, it should be directly proportional to the product of the masses. It means you need to find the product of masses like this. F is directly proportional to what? M1 and the M2. This is the first statement, okay? Then you need to take the second case, and number 2 is what? Inversely, it should be inversely proportional to what? Square of the distance between them, or between the masses. Let's say between them here. So how do you say? F is inversely proportional to r square. Okay, so when you combine the two relation, what do you get it? F is proportional to what? M1 and the M2 divided by r square. So this statement is here. This is the statement. Okay, so you check it, and I know that most of you happen to answer this well. It's okay, very good. Let's take it one more time, and I tell you one more time here. The grammatically it may not be exactly the same as what you happen to copy from book. But we are not looking for grammar here, we are just looking for the concept, okay? So if the concept is very clear, that's okay, fine. You don't have to worry about, right? Then, in the second part of the question, what it says. You need to define it. You need to define, what is that? You need to define the universal gravitational constant Z. Okay. So now let's see, how do we define it? Take the two mass again here. This one. This equation we have seen F is equal to Z m1 m2 by how much? R squared. The equation one more time. Okay. So now if you take this mass, this one, the first mass, take it as 1 kg. The second mass, just take it as what? Also 1 kg. The same mass, okay? 1 kg, take it like this. Then you keep them 1 meter far. How far? 1 meter far. Okay. So if you do like this, what we do? Just say if m1 is equal to 1 kg, let us say m2 also 1 kg, let us say m1 is 1 kg, m2 is also 1 kg, and the r, the distance be taken as what? 1 meter. Okay. So if you take this gases, you put in the equation. Therefore, you become you write what? F is equal to Z 1 into 1 divided by 1 square. Is not that 1 into 1 divided by 1 square means what? This is going to be 1. So or you can write F is equal to what? Z here. F is equal to Z. Now this is a very important part. Okay, this is the part that most of you happen to miss. Okay, so how do we define this? Now listen carefully. Universal gravitational constant Z, I repeat again, universal gravitational constant Z is defined as the attractive force. Here between these two there is an attractive force. Okay, the attractive force, this is defined as the attractive force between two masses, each of 1 kg, separated by a distance of 1 meter. This is the way how we define it. Okay, just imagine, say I keep these two pens, for example, say this is these are the two objects, let's say. Let's zoom out the camera. These are the two objects, let's say. This is what is the mass of this pen? Red pen is the 1 kg. This is also 1 kg. Okay, 1 kg. How far? 1 meter far. Right. Then at this time is what? When you take this as 1 kg, this also 1 kg, and you keep them 1 meter far. At this time, there is a force attracting between them. Okay, there is a force attracting between them. So that attractive force is what we define as universal gravitational constant. Okay, so don't forget it. The universal gravitational constant Z is defined as the force, as the attractive force between two masses, each of 1 kg, separated by how much? 1 meter distance. Okay, there is a way you have to define it. So just for definition, I think you can write down from the dictation that I made. Okay, then we'll go to the second question. In the second question, what is the second question says? The second question says that you need to write down the laws of gravitation in the vector form. After writing in the vector form, you have to show that the two forces are equal in magnitude but in opposite direction. Okay, but before I continue, just I wanted to show you. Just take one chapter. Okay. In the scalar form, we have written as F is equal to what? Z m1 m2 by how much? R squared. This is scalar form. Scalar form means what? No direction. Okay, no direction, only the value. Okay, this is what? Scalar form. And what is the other one? F in the vector form. Vector form is what? Having direction. Okay, having direction. Z m1 m2 by R squared. Then what? There should be another vector R cap. This is the vector form, and this is what we call as the unit vector. Sometimes we call as what? R cap, just like the head. Okay, I know you're confusing here. Don't be. I'll be teaching you vector and scalar quantities separately in a separate class. Just for time being, remember that if you write in the scalar form, this is a scalar form, no direction, no arrow. Okay, but if you write in the vector form, equation becomes like this. Just try to know the two. Okay, the difference of the two. Now coming back to our derivation, this is the first mass, the second mass here. So let me write as m1. This is m2. Now I separate them by a distance of r here. Okay, then let us think that m2 is pulling m1, M2 is pulling M1. So the direction of the force is F12, let us say. It means let F12 be the one, the force on M1 by whom? M2. Means the M2 is pulling M1. Okay, with how much force? F12 force. Okay. Similarly, M1 is pulling M2 again. M1 is pulling M2 because attracting means by pulling each other. So in this direction. So this is what F21. So now I will say that F21 is the, what is the force on whom? M2 by whom? M1. Sorry, I'm just speeding up, okay, because time is running up. I need to post it before 10. I have already recorded the other video. Very angry today. I lost it totally. The other video was, a bit slow in explanation. I'm doing it hurriedly. I need to upload again. Okay then. This is the case. So in other words, just think like this. F12 is the force on M1 produced by M2, and F21 is the force on M2 produced by M1. Something like pulling like this. Okay. Then use the Newton's laws of gravitation. What is that? Okay, but before that, we need to take the unit vector. So let's take the unit vector here. R again, r cap. But look the direction. I am taking like this here, in this direction, from starting from 1 going towards the second mass here, R12. Okay, so like that, take the unit vector here, again R here, starting from 2, going from 2, going towards the 1 here, R21 cap. Okay, so you have got two unit vector. It means these are two masses, M1, this is M2. R12 2 from 1 to 2, another one is R2 to 1 here, 2 to 1 here, like this. Okay, so what we do? F12, this is equal to Z, put the masses M1, M2 divided by R square, and you put the unit vector R cap here. You choose the unit vector in the same direction of F12, having the same direction of F12. F12 is here in this direction from left to right. So you have this R12, you can see R12 also from left to right. Okay, so you have to write R12 cap here. This is equation number 1. Okay, and the another one is F21. You look for the other one, F21. The same thing, Z M1 M2 divided by R square. Then take the unit vector, take the R cap having the same direction of, or having the same direction as what? F21 here, F21. Okay. So it's nothing but R21, right? So I need to take R21 here, R21 cap here. This is equation number 2. Okay. So now we have got two equations. But remember, from the vector algebra, I have not taught you yet. Just for time being, remember this formula. R12 cap. This is equal to R21. You can see R12 is equal to R21. But there should be minus here. There should be opposition. So don't forget this. R12 is equal to what? Minus R21. If you reverse the 2, but there should be negative sign coming up here. Okay? So using this, you put in the above formula. So you can put in the first equation. Here you can put it here. So F12 now becomes what? Z M1 M2 divided by R squared. So instead of R12, what can you write? Instead of R12, you can write minus R21 cap here. Okay, check it one more time. This one R12, I'm just putting here. Okay, like this. Then you can write minus, I'm taking here minus Z M1 M2 by R squared into what? R21 cap again. Okay, so what do you have? This one, if you look the whole thing here, what is this? Is equal to, you can take it here, G M1 M2 R square R21 here, Z M1 M2 by R square R21 is, this one is nothing but exactly what? F21 here. Okay, is F21. So in other words, what do you have? This part, instead of this whole part, instead of this, you cannot see it here, instead of this, check it one more time. You just zoom it out. So you can see, instead of this part, you can replace it by this one here. These two are the same. This and this are the same. Okay. So what I do, I write minus here. So instead of this part, I write as what? F21 vector. Okay, in other words, F12 is equal to what? F12 is equal to, 2 minutes again, F12 is equal to minus F21 here. So what does it mean? It means that the two forces are equal in magnitude but opposite direction. The two forces are equal in magnitude but opposite in direction. Okay? So this is the one, and just some more tips that I want to give you. I'm losing most of my time. I don't know whether you see me or not. Anyway, I'll just show it. Okay? Some tips that I want to include. Next time, whenever some assignment is given, you please try to submit in time. And to learn the subject physics properly, you have to observe the surrounding. Okay, try to observe the whole surrounding. If it's like what is going on, for example, say what things are happening in our surrounding, you try to study these things, because physics is the study of natural laws. This is the study of natural laws. Okay, physics is the study of natural laws. So in nature, what is happening, we have to see that properly, and try to revise well. Every class which is sent to you, you take it very seriously and you revise it well. Okay, only in that way you can learn physics better. Anyway, for today I'll stop. Okay, and I need to go and I need to upload the video right now again. All right.